What's up, Algebra 2? This video is going to cover some compounded continuously problems, compounded quarterly, just different types of compounded interest problems, as well as how to do exponential growth or decay models using a regression. So let's jump right into it. So the first one is asking us about a $500 prize and you could invest it for 4%. And how much would you have in 15 years if, and you have these two separate cases. So one of them is compounded continuously, and that's the PERT formula. We're going to memorize that hopefully. And then the account compounded quarterly, we're just going to use the compounded interest formula where you basically have to divide and multiply by whatever the word that represents how many times you do something in a year or in whatever time frame you're doing. And this is quarterly, and so quarterly represents 4. So we have to take this number and divide by 100 in order to get the interest value as a decimal. So that's going to be 0.04 and of course 15 years. So when we plug all that into the calculator on the first one, we're going to get 911.06. Okay. And then when we do the second equation, we're going to get 500, but it's multiplying against this interest of 0.04 divided by 4, and then raised to that 4 times 15. And of course, you should always expect compounded continuously to be the most interest or the most gain or percentage you can have from a compounded situation. It should always be the greatest. And we see that here, 908 when it's quarterly. And then when it's compounded continuously, we see a slight increase. Not too much, but it is slightly greater because that's the most we can have in terms of interest time frame is that continuously process. All right, so as we go to the next one, I want you guys to really try this one on your own. We're going to check it in class. I want you to think about like which formula you should use based on the information given. All right, guys, so I went ahead and tried to fill in some information here, but let's kind of read it together. The table represents the average annual salary of an NBA athlete in thousands of dollars. So that means when you look over here, this is time after 1980. So this is really 1985, 1990, 1995. And then in terms of salary, how they've increased. So a lot of times people use the regression process to take data and start thinking about what will happen later. And of course, that's C, use the equation to find 20 years later. So here we go. So find an exponential equation. And so we have to go to stat, edit. And when you do stat edit, it's not letting me click it. Hold on. When you go to stat edit, we got to put in all the information from the table. Okay, and there's a real good reason why we're not putting the actual years in here, and we'll talk about that here in a minute. But once you do that, of course, we're going to go to stat, go right, and you can scroll all the way down to number 0, and that's exponential regression. So once you see EXP, REG, or you could just hit 0, it goes right straight to it. We're going to have this screen, and I'm going to just go down here for just a second. If you want to store the equation like to the 10th decimal place or whatever, this can be a useful thing. I do variables, I scroll right once, I choose the first option function, and then the last thing I also do is choose Y1. And now whenever I calculate this, not only does it give me the equation 161.4299, it also tells me the B value, and this is going a long different way from just rounding off the value if I have it in Y equals as that exact number. Okay, now I don't have to use the main screen to try to figure out a way to estimate that value and not really using as many decimal places as I should or as I could. Now this 2 to the 1980, that's the reason why we don't let the year actually be the year, is we can't actually plug in anything that has that large of a value. Okay, so now once we have this written down, and I do estimate it on paper, I'm going to use that equation now to figure out that this was 16.9%, just moving the decimal place off that 1. It's a little harder when it's decreasing, when it's 0.9 something. That can be a little tricky too. But this one, I'm just kind of peeling these numbers off and moving the decimal twice to get the growth rate as a percent. Now I want to figure out what would happen if I took 20, which again is time, that's input, and I like plugged it in for this t. Okay, plugging in 20. All right, so if you go to the calculator and you've stored it, what's awesome is you can go to the table and go and find 20. And there you go. So that's like $3,678,600. I mean, that's a lot of money. Remember, it's in hundreds of thousands just so that we can keep the numbers a little more manageable, smaller numbers. They mean bigger ideas. All right, so that's the process there. And I want y'all to think about, just for MBA sake, and just critical thinking, what happened in that 10th year after 1980, that 15th year. Just think about it, and we'll talk about it tomorrow. And then we'll try to think about what's going to happen in 2050 or 2100. Like, what is the future of NBA players' salaries, and where can it go? So the last part we're going to talk about real quick is these questions that have to do more with exponential growth, but also some of the rules that we talked about that kind of dance around equivalency within these power rules. And so we'll kind of do some examples there. So $4 today invested 3 times as much on each consecutive day. So $4 is your A value, that's your initial value. 3 is your B, so it's A times B to the X power. So this is 4 times 3 to the whatever power. And it says T for days, so I'll just make this a little T, okay? So you may be wondering, like, how do I dance within all these different formulas? Well, the truth is that they all have a similar concept of A times B to the X. Like, P is your A, E is your B, and then your power is just whatever that multiplies together to be, okay? So that could just be your X. X is RT in that case. Or in this one, there's your initial value, and then whatever this has combined, like whatever that value is in the end, and then it's raised to the NT, which in this case is whatever X is, So they have that common theme of like initial value, the growth value that's like either above 1 or below 1, and then its power. And so once you really grasp that, you really see that within everything, and you can kind of categorize it in terms of like its own formula, or if it really just kind of lives within that A times B to the X power. And this one really is simple when you approach it with A and B, is A is what you start with and B is the multiplier. So that's kind of our equation. Write an equation to represent Y after T days. So the only thing we'll do to finish it off is do like a Y equals there, and then we're done. So after how many days will she invest 972? Okay. So this right here is trying to see like when the outcome is 972, okay? Because he invests $4 a day, 3 times as much on each consecutive day. So he's like investing more. And so 972 equals 4 times 3 to the T. Now maybe it's hard to think about where to put that value, but if you think about it, the dollars is the Y, that's the outcome, and T, like this is definitely not time, it's dollars, so it can't be T, that's days. It can't be $972 days, it doesn't make sense. So it has to be in the other place. So let's solve this by dividing by 4. Okay, and that is super sloppy, but let's just go to the calculator real quick. I don't want to use this calculator, let's use the nice calculator. So 972 divided by the 4. Okay, and that's 243. So when I have 243, that equals, I'm going to do it this way, equals 3 to the T. Okay, I'm going to give you just a few seconds to think what I use to solve for something that has a power that's unknown. And this is probably the first class you've ever taken that made you learn this, but it's logs. Okay, log is exactly what that does, is it helps you figure out what that would be, okay? So there's other ways you can do this, but this is what I want you to learn. So this is log base 3 would produce 243 if it was raised to the X power, okay? And so when you can say that as you write it or type it or whatever, it really makes a full understanding of like what this means in terms of what this means, okay? So I'm going to type that in the calculator. Let's do log 243, and I'm actually using the common log because I think it's just, I don't know, it's just easier for me. So that gives you 5. What that means is 3 raised to the 5th is exactly that 243. And then once you multiply that by 4, that's where you see 972 exactly. So 5 is your answer in terms of days. How many days? 5 days. That's how long it's going to take. So again, just being able to like establish that formula, take the next step to plug it in, and be able to reverse solve for it using like key Algebra 2 skills that I hope we're starting to establish. They're difficult, but I think you can do it. So which of these are equivalent to your equation? So we talked about how to split up some of the ways that you have these numbers 3 raised to like x plus 2 power or 12t or whatever. So this one is 2 times 3 to the x power times 3 squared, because if you wanted to put two bases together by multiplying them, you would really just add their power. So if that's what it is here, then you could move backward and say, well, that was originally 3 to the x times 3 squared. Well, 3 squared is really 9, and it's multiplying against anything that it can hit, including that 2 there. So that's actually giving us 18 times 3 to the x. Okay, that is our equation. So that's kind of the target here, and I'm going to see if I can get that value out of any of the other ones. So this is 3 to the x times 3 to the 1. Okay, now it has this 4/3 in front of that, and so I'm really happy that I see a 3 in the denominator, and then it's multiplying by 3 to the 1, which is just 3. So these end up canceling, and you basically have 4 times 3 to the x. And of course, that's not the same. So then let's see which one this one comes out to be. So hopefully on your paper it says 1/12. And so these can kind of go together like power kind of deal, and they end up canceling out. And it gives you 2 times 3 to the x or the t or the whatever. Okay? So actually, none of them are equivalent. That's the answer here. Okay? So hopefully those will be something we can practice a little bit tomorrow. But again, I really want us to start thinking about the regressions and how we can practice that in class tomorrow. So I hope this video has helped. I will see you guys tomorrow in class.